On August 27, 1883, the loudest ever recorded sound was heard from as far away as 4,800 kilometers from its origin. This sound was the final eruption of Krakatoa. This explosion occurred because cracks in the volcanic walls allowed seawater to enter the magma chamber. After the water entered, the magma superheated the water into steam, which increased the pressure inside the volcano until it exploded, destroying a majority of the island in the process. The blast from this explosion was equal to 200 megatons of TNT. While this explosion on August 27th is the final eruption of Krakatoa, it began erupting on May 20th, 1883. The eruption of Krakatoa is listed on the Volcanic Explosivity Index, or VEI, as a 6, which stands for colossal. Since this eruption occurred during a period in time when humans were present in recording history, there are first-hand accounts of how the eruption affected the Earth. The idea that volcanic eruptions are intensified by the addition of water makes logical sense. If you mix water and a high-temperature material together in a confined space, the water will evaporate into superheated steam. When water turns into superheated steam, it expands, increasing the pressure inside of its container, which in this case is the volcano. With this increased pressure inside the volcano, it causes the explosion to be larger than if there is no water present. This theory was proposed by Professor J. W. Judd. The amount of water in the lava can be measured based on its viscosity. The change in the viscosity of the lava shows the varying water content present at different times. After water entered the volcano, it began to vaporize and expand, which increased the pressure. Once the pressure became too much for the volcanic walls to hold, it exploded loudly with a lot of force. Now, when I say that Krakatoa exploded, you might get the impression that the volcanic cones fragmented and was sent into the sky. In fact, this is what they believe happened initially after the explosion. However, by looking at the material from the explosion that landed on nearby islands and analyzing it, scientists found that this was not what occurred. The explosion left up to 200 feet of debris on nearby islands. After analyzing this rock and ash, it was determined that the presence of older rock, which is what the volcanic cones were made out of, made up less than 10% of the total volume that was missing from the island. This means that a majority of the material that was expelled when Krakatoa exploded was magma that came from within the Earth. After analyzing the rock and ash that was expelled, scientists determined that the volcanic cone sank down partially underwater after the explosion, since the magma that had been underneath it and supporting it was now gone. To visualize how the explosion occurred, imagine that you have a pressurized canister and you puncture it. Since the pressure is higher on the inside of the container, the contents move outside of the container to an area of lower pressure. This is a very simplified version of the Krakatoa explosion. After the magma flowed out of the volcano, the sheer weight of the rock caused it to collapse on itself. One of the reasons that we know so much about the eruption of Krakatoa is that there was recording of the event by people who survived through it. Since we know what the geography of the area was before the explosion, we can see how it affected the landscape. The eruption of Krakatoa destroyed 2/3 of the island where it was located. There are first-hand accounts of the tsunamis that resulted from the explosion. While the island itself was uninhabited, Fishermen observed the volcano as they passed by. In 1927, it was discovered that the volcano had begun erupting and eventually formed a small island that is known as Anak Krakatoa, or Child of Krakatoa. While these eruptions are smaller eruptions, they continue to expand the island. Since there were humans on the Earth when this explosion occurred, there are unique ways to gather information about the eruption of Krakatoa. One source of information about the eruption can be found in paintings and written accounts from Edvard Munch, who is a Norwegian artist that was alive when the eruption occurred. Although his famous painting, The Scream, was not painted until 10 years after the eruption, it is a visual representation of what the sky looked like in Norway after Krakatoa erupted. In addition to his most famous work, he also made paintings and drawings that are more specific about the details of the environment where he was painting. In the painting Scream, the sky appears a naturally reddish orange. The coloring of the sky is a result of the Krakatoa eruption and all of the ash and aerosols it released into the atmosphere when it erupted. In addition to this piece of art, there are various written accounts of the amazing sunsets that occurred after the eruption as a result of the gases that the volcano released. The cause of these brilliant sunsets was particles that had been launched into the atmosphere during the explosion. These particles included acidic aerosols and volcanic dust. The finest particles were sent farthest into the atmosphere and were suspended throughout the atmosphere for years after the explosion occurred. In addition to the change in the color of the sun, the dust that was now present in the atmosphere blocked out some of the sunlight. When this sunlight was blocked, the overall temperature of the Earth decreased by a few degrees. The volcano also released sulfur dioxide gas when it exploded, which reacted with water to make sulfuric acid. This first-hand observation of a volcanic eruption's effect on global temperatures can be used by geologists when studying other time periods. Specifically, this information can be used to determine if a volcanic event can cause an extinction and how large that eruption would have to be. The dust from this eruption spread throughout the world. This can be seen in the work of Joseph Wharton. His interaction with Krakatoa comes from collecting samples from the air in Philadelphia, Pennsylvania. He did this by collecting snow and then isolating the solid matter. What was left was small dust that he then examined under a microscope. This dust that he found had volcanic glass characteristics. This direct observance of volcanic dust proves that an eruption in one part of the world can have an impact on other parts of the world. This dust was found 4 months after the Krakatoa eruption, which also shows that volcanic dust can remain in the atmosphere for long periods of time. Also, when observing the sample, Wharton found that there is no pyroxene, auxite, or magnetite present in the sample. He theorized that this was because these heavier particles fell out of the atmosphere before they could reach all the way to Pennsylvania. Krakatoa's explosion drastically altered the ecosystem of the island. When the island was visited 9 months after the explosion by French botanist E. Krakatoa, the only form of life he could find was a single spider. when the island was visited 3 years after the explosion. There were many plants growing along the coast, but farther inland, the plant life was limited to ferns and grasses. It took until about 1930, which was nearly 50 years after the explosion, for the entire island to be once again covered with dense forests. Since this eruption occurred during a time in human history, it gave scientists alive at the time a unique opportunity to study how seeds are transported in between islands, because they could see which plants spread the fastest since they were all wiped out when Krakatoa exploded. The eruption of Krakatoa is the loudest recorded sound. Its eruption sent nearly 5 cubic miles of fragments into the atmosphere, with ash falling over 300,000 square miles. The ash from the volcano even caused 2.5 days of darkness in the surrounding area. Since it occurred in 1883, it has been recorded in human history, and scientists could gather recent samples from around the eruption site. This eruption also gave scientists the opportunity to see how plants travel to islands as seeds and their speed of travel. This eruption has been studied by many scientists, and we now know that the water that entered the volcano is what intensified its eruption into the huge spectacle that it was.